All right, let's dive in. Today, we're going to pull back the curtain on one of the most important ideas in all of machine learning, linear regression. Now, I know that sounds a little technical, but I promise you the core idea is actually something you can see and understand, and it all starts with a really simple question. See? This is the exact kind of problem we're talking about. We have one thing we know, how many hours you studied, and we want to predict another thing, what your test score is going to be. This is precisely what linear regression was built for. It's a tool that helps us find a pattern in things that have already happened so we can make a really good guess about the future. So what is this prediction machine really trying to do? Let's forget the fancy name for a minute. At its heart, the goal is so simple you could basically do it with a piece of paper and a pencil. That's it. No, seriously, that's the whole goal. Just imagine a graph where every little dot is a student. Going side to side is how many hours they studied, and going up and down is the score they got. The goal of linear regression is to just draw the one single perfect straight line that slices right through the middle of all those dots. Once you have that line, you can use it to predict anyone's score. Okay, so we get what it's trying to do, find that perfect line, but how does a computer actually figure out where to draw it? It doesn't have eyes or a ruler. Well, it turns out it learns in a way that's surprisingly human, by just guessing and checking. Think about it this way. When you're learning to shoot a basketball, your first shot might be a total air ball, right? It goes way off, but you don't just give up. You think, okay, that was way too strong, or I need to aim a little higher. You see how wrong you were, you adjust your shot, and you try again and again. And each time you get a little bit closer. Well, the computer is doing the exact same thing. This whole learning thing happens in a constant loop. First, the computer just throws a random line on the graph. That's its first guess. Then it checks how good that guess was by measuring how far away the line is from all the real dots. It gives itself a wrongness score. Based on that score, it nudges the line a little bit to make it better, and then it does it all over again and again, thousands of times, getting a tiny bit closer to the perfect line with every single try. Now, for the computer to run that learning loop, it needs a few tools in its toolbox. Let's break down the 3 essential pieces that make this whole process work. This is kind of the how behind the magic. First up is the equation for a line. Now, don't worry, you do not need to do any math here, I promise. All you need to know is that any straight line in the universe can be described with just 2 numbers, m, which is how steep the line is, and b, which is where the line starts. So when the computer makes a guess, all it's really doing is trying out different numbers for m and b. So how does the computer know if its guess is any good? It uses something called mean squared error, or MSE. Just think of it as a badness score. It's a single number that tells you how far off, on average, the line is from all the real data points. A high score means the line is a terrible fit. A low score means it's a great fit. The computer's one and only mission is to get the score as close to 0 as it possibly can. And finally, we have the coolest tool of all, gradient descent. This is the really smart part. After the computer gets its badness score, gradient descent is the clever bit of math that tells it exactly how to change m and b to make the score lower on the next try. It's like a magical compass that always points downhill, towards less wrong. This is how the computer intelligently adjusts its aim instead of just guessing all over the place. But hold on, there's a potential trap here. How do we know the computer is actually learning the real pattern and not just memorizing the dots we showed it? Like cramming for a test? Well, to make sure it's not cheating, we use a really important trick. We split our data into 2 piles. The first pile is the training data. You can think of this as a huge stack of practice problems. The computer gets to study this data as much as it wants to find the best line. The second pile is the testing data. This is like the final exam. We keep this data totally secret from the computer while it's learning. Only at the very end, when it thinks it's ready, do we test its line on data it has never, ever seen before. That's how we prove it actually learned the concept, not just memorized the answers. So, we've gone through what it is and how it works, but why does this one simple idea matter so much in the huge world of AI? Let's zoom out for a second and look at the big aha moments here. The first big takeaway is this: don't let the fancy names intimidate you. When you hear things like linear regression or gradient descent, at the end of the day, it's all about one simple visual goal: drawing the best possible straight line through a bunch of dots. That's really it. The second key thing is that the way it learns is so familiar, right? It learns just like we do. You make a guess, you see how wrong you are, you make an adjustment, and you try again. The computer is just running that same simple loop with math, but it's doing it thousands of times a second. And that leads to the real beauty of this whole thing. We don't have to sit there with a calculator trying to figure out the perfect M and B ourselves. We just tell the computer the goal. Hey, get that error score as low as you can. And the algorithm automatically does all the heavy lifting to find the best possible answer for us. And this right here is the most important part. This simple self-correcting loop of guess, check, adjust isn't just for drawing lines. It is the fundamental idea that powers so much of modern AI, from simple predictions all the way up to the most complicated systems you can imagine. By understanding this one simple process, you've really taken your first, most important step into understanding how machines actually learn. So think about it. What other everyday problems could this simple idea help us solve?